This is the setup for the current experiment. The syringe is a 30 milliliter syringe. It's bigger than the one described in your manual. It is connected directly to the pressure sensor, and you see the pressure monitor in the bottom left corner of the screen. The sensor is connected through the vernier interface to the USB port of the computer. When you launch Logger Pro, depending on the type of sensors that you have connected to the interface, the program recognizes these sensors and shows them up here where you can change their calibration, their parameters as needed. And here we have a pressure sensor connected to channel 1 and a temperature sensor connected to channel 2. We're not going to do any calibration now, so we can close here. Of course, you will not have this because for this you have to have the sensors connected. When you launch Logger Pro and there are no sensors connected, you will get the message, no sensors are connected. Do you want to continue without data collection? And in that case, you will say yes. If you go to Files, Open, there will be a series of experiments that are provided when you do the installation, and the experiments for this lab are found under Advanced Chemistry with Vernier. Double click there and proceed to Files 30A, B, C. These are the 3 files you're going to use for this experiment. I'm going to open the first one. This is the first experiment in which we're going to study the relationship between the pressure and the volume of the gas. So I go open here. As you can see, only the pressure sensor is recognized here. And now it's about time to start the data collection. To do the data collection, and this part, you will say collect. And for every data point that you want to register, for example, at this moment, the syringe that measures the volume is indicating 20 milliliters. So you press the knob keep and manually enter the volume 20 milliliters. Say OK, and that registers one data point. Then if you change the volume, let's say to 15, of course the pressure increases correspondingly, and you will say again keep, and this is for 15. Okay, and then for 10 you go all the way here and you say keep volume 10, okay. Then you can release. As you see, you have collected the points there. You can now go back in the direction to less pressure, and I got here to 25, keep 25, okay. And in that way you will collect all the data points for this experiment. I'm not gonna continue because you're gonna use the ones that were collected during the film. At this point you stop the data collection and you have here the numbers that you want to use. Now to fit a line through these numbers, first you will try different curve fittings. In the first case, you will try curve fit, and if you have read the introduction, you know that we expect here an inverse relationship. So this is to be the best fit you can get through the points. You can say try the fit. It fits pretty well the numbers. So say okay, and you will have the curve fit in terms of the inverse relationship between the pressure and the volume. But you know that Boyle's law generally is plotted not in terms of the volume, but in terms of the inverse volume. To succeed doing that, you can go to data, add calculated column, 1 over volume. You can give it also short name, 1 over V, and units, 1 over milliliter. And then click on the expression, and you're going to tell that this new column, 1 over V, is going to be equal to 1 over, and select here from the variables the variable volume, and you say done, and it has added the column of the inverse volume in inverse milliliter. You want now a new graph. You go to insert graph, and in this graph, in the y-axis, you want the pressure. You need to click here where the label is and select the pressure there. And in the x-axis, you want the inverse volume. And as you can see, the inverse, the pressure plotted versus the inverse volume is a straight line. You can check this by going to analyze linear fit, and it's a very good straight line that features other points. And this is the manifestation of Boyle's law. And that's what you need to do with the data for this and for the rest of the experiments in this lab.